All right, let's talk all about circles. Part of this lesson will be review. You should already know that the circumference of a circle is 2 pi r, 2 times pi times the radius, or in other words, pi times the diameter. So that first example on your notes, we're finding the circumference of a circle where the radius is 9 centimeters. So if I plug in 9 for r, I have 2 times pi times 9, which is 18 pi. And our units are centimeters. So remember, circumference is like the perimeter of a circle, the distance around the circle. So because we're talking about distance, we do not square our units, just 18 pi centimeters, or if we type that into our calculators, that's about 56.5 centimeters. I typically like, that does not look like an approximate sign. I typically like the exact answer when it's possible, but this also works. Just make sure you're using the pi button on your calculator. Then we can also use that formula to work backwards. If we know the circumference is 26 and we're looking for the radius, in this case it's going to be impossible to keep pi as, well, not impossible, but we don't want to keep pi as part of our answer. To get radius by itself, we need to divide by 2 pi. Divide by 2 pi. So if I take 26 divided by 2 pi, I get about 4.1 meters is my radius. So quick overview because that part's review. Let's get to some new things. On slide 2, we want to know how far this tire is going to travel if it makes 15 revolutions. So think about 1 revolution. So we're going around 1 time. That is talking about the circumference. So whenever you see the word revolution, think circumference. 1 revolution is really just the circumference. All right, so let's start by finding the circumference of this wheel. We can look for the radius, a little bit easier to find the diameter in this case. If we add all those pieces together, we get that the diameter is 26 inches. 5 plus 15.5 plus 5. Or you could say that the radius is 13 inches. Either way is fine. When we use our circumference formula, then our circumference is 26 pi. So in other words, 1 revolution is going to take us 26 pi, which means 15 revolutions, we would just multiply 26 by 15 and get 390 pi. But you wouldn't say, oh, if your wheel makes 15 revolutions, you're going about 390 pi inches. No, you wouldn't say that. And so we would, in this case, want to take 390 times pi, and we get about 1,225 inches. Is how far your wheel would travel in 15 revolutions. And then the second example, very similar question. It says that your car has a diameter of 28 inches. How many revolutions does it make if it goes 500 feet? All right, so changing the game a little bit here. Now the diameter is 28 inches. So our circumference is 28 pi. Which means 1 revolution is 28 pi. Let's go ahead and calculate what that would be. 28 pi is about 88. I'm just going to go ahead and round it, 88 inches. So 1 revolution, it would travel 88 inches, and it wants to know how many revolutions it makes if it goes 500 feet. All right, so it goes 88 inches in 1 revolution, but now we're going 500 feet. So how many inches are in 500 feet? Well, if I take 500 times 12, 12 times 5 is 60, so 6,000 inches. We're going 6,000 inches. And each time we go around, we go 88 inches. So if I take 6,000 divided by 88, it would mean that we made about 68 revolutions. All right, here's one of our big hitters for today, arc length. This is new. Circumference is the distance all the way around the circle. Arc length is just the distance from point A to point B on the circle. So not all the way around the circle, just part of the circle's distance. So let's talk through arc length by doing one of the examples on your notes. This is on the third slide. There are two different kind of formulas there for finding arc length on that slide. The one that we're going to use the most is actually going to be that proportion, that top one. So how it says to set it up is our arc length. So I'll write arc length here. So the length from A to B is proportional to the, so the ratio, I should say, of the arc length to the circumference, so circumference is all the way around, is proportional, I'm going to go ahead and write circumference, to the ratio of the measure of AB to the measure of the whole circle. And we know a whole circle, the measure of a whole circle is 360 degrees. So that will always say 360 degrees. So let's break that down a little bit more. Again, let me say it a different way. So basically we're doing part to whole, part to whole. The length of part of the circle over the length of the whole circle equals the measure of part of the circle over the measure of the whole circle. That's what your proportion is going to look like each time. So for this particular example, we don't know the arc length. This is what we're looking for. I can go ahead and substitute that with an X if I want to. So I'll put an X there because that's what we're looking for. We don't technically know the circumference of the circle just by looking at it, but we can find the circumference of the circle because we know the radius is 8. So the circumference of this circle, 2 pi r, so 2 times pi times 8, or 16 pi. So the distance around the whole circle is 16 pi. We don't know the distance from A to B, that's what we're looking for. We do know the measure from A to B though, based off of our circle unit, is 60 degrees. So from A to B is 60 degrees out of the whole 360. So we have our proportion says x over 16 pi equals 60 over 360. And if I were to solve this, a couple of different ways to do this. We've got 1/6. Let's just cross multiply. That's going to be the easiest way. So we're going to take 16 pi times 60. Sorry, I think through the easiest way to explain this. Let's just cross multiply. 16 pi times 60. So that's going to be 960 pi equals 360x. Divide both sides by 360. And I like nice, pretty answers. So if I were to reduce 960 over 360, I actually get 8/3 pi. Or I can go ahead and take 960 times pi, then divide that by 360, and we get about 8.4 centimeters. So my exact answer would be 8/3 pi, if I left it in terms of pi, or 8.4 centimeters. So that means the distance around the whole circle is 16 times pi, but just that little piece is about 8.4 centimeters. Let's do another example of that. Same slide, third example, let's find the distance from G to H. So we know the measure from G to H is 120 degrees. So when we set up our proportion, we know that the part of the circle we're looking for is 120 degrees out of the whole circle, which is 360 degrees. We're looking for the length from G to H. So we're looking for the length of part of the circle. We can find the length all the way around the circle. That's the circumference. So the circumference of this circle, 2 pi r, is 2 times pi times 11, because our radius is 11. So that's 22 pi, and just to make this easier, I'm just going to go ahead and take 22 pi, and I get about 69.1. So the distance all the way around the circle is about 69.1. So when I cross multiply here, I'm going to take 69.1 times 120 divided by 360. And so I get that the distance from G to H is about 23.0, and these units were centimeters. So all the way around the circle was 69.1 centimeters-ish, and from G to H is about 23 centimeters. The reason I like using the proportion, so I'm on the next slide, first example, is even if we're missing something other than the arc length, we can use the proportion to figure out what's missing. So for this example, we're missing the circumference. We're missing the length around the whole circle. We know the length of part of the circle. The length of the x to y is 4.19. We do not know the length around the whole circle. We know the measure from x to y is 40 degrees. And of course, we always know the measure of the whole circle is 360 degrees. So remember, this is like part to whole, part to whole. Part of the circle is 4.19, and that's 40 degrees out of the whole 360. We're missing the length all the way around the circle. So once you've plugged in everything, we just cross multiply to solve, and you should get that the circumference is about 37.71 inches. Let's do one more of those. All right, last example from the front side. We're looking for the measure of RS. Notice that we know what the length from R to S is. It tells us that the length is 44 meters. So we know from R to S, the length is 44 meters. What we're missing is how many degrees it is from R to S. So those are our parts. R to S are our parts. The whole circle then, we know, is always 360 degrees, and we can find the length around the whole circle by finding the circumference. It tells us the radius is 15.28, so circumference is 2 times pi times radius. So if I take 2 times pi times radius, I get about 96 meters. So the distance around the whole circle is 96 meters. The distance around the part we want is 44. Now we cross multiply to find out how many degrees that is. So 44 times 360 divided by 96. So that means from R to S is about 165 degrees. So use the proportion. Make sure you know it's just part to whole, part to whole. And then cross multiply to find the missing piece of information. You will always know this number is 360 degrees. So if you know the part of the circle that goes there, and then this part is talking about the distance, not the measure. So these will have units. These will always be in degrees. Circumference, arc length, degree of the whole circle is 360. Degree of the piece would go on top, or the measure of the arc would go on top.